Okay, today we are taking notes on stellar evolution or the life cycle of stars. This is part one. There are only 12 slides. Okay, star formation. All stars begin as a stellar or solar nebula. All that is a cloud of gas and dust. It is theorized that the gas and dust formed as a result of another star's collapse. Once that stellar or solar nebula forms, you get a protostar in the center of it. A protostar is like a baby star. It's a brand new star, very, very young. And that's formed from the nebula that collapses due to the force of gravity. After the nebula collapses, fusion reactions begin, and voila, there's your new star. Now, at this point, the life cycle of the star has already been determined due to the amount of mass it began with. So right at the beginning, its life cycle is already determined because of the mass it contains. Okay, right here, we have the star life cycle. You need to draw and label this. I am aware that it is a lot, but there's nothing I can do about it. If you want to copy the page, do a screenshot, or if you go to snipping, I don't know if you all know about snipping tools, but snipping tools, I can't get to them now. Snipping tools are generally under File, and you can find where it says snipping tool. You can actually copy that whole page all at once. So you're more than welcome to do that and then bring it to class. All this is showing is the life cycle of a star. Right when you have that nebula collapse and a brand new star is formed, that's right here at the very beginning. Okay, the life cycle of our sun, it literally goes from birth. It is roughly 4.5 billion years right now. Okay, it will turn into a red giant, a planetary nebula, and eventually a white dwarf. The life cycle of other stars, okay, besides our own, start as a nebula. All stars go to a main sequence, and from here, depending on their mass, they take two routes. If they have a really, really high mass, they turn into a supergiant, which is really, really big. Then it turns into a supernova. So imagine like a explosion in the sky. The supergiant explodes. It sends away its outer layers, and the supernova is born. And from there, it can do two different things, once again, depending on that initial mass. If it has a smaller mass, where's my mouse? It becomes a neutron star, where the core collapses and becomes very dense. If it has a really high mass, it turns into a black hole, where the core collapses completely and it acts like a vacuum. Our star, the sun, goes from our little protostar to the main sequence. And then because our star is actually really boring, it's just a medium-sized boring star with low mass, it turns into a red giant. Where's my mouse? There it is. A red giant, a planetary nebula. Okay, it has an outer layer of gas that literally kind of puffs off, and the hot core is exposed as a white dwarf, which is the next phase. That white dwarf will eventually cool and turn into a black dwarf, and the star stops glowing. And this basically goes through what I just said. The protostar turns into a medium star, the medium turns into a red giant, and depending on its mass, the red giant with low mass becomes a white dwarf, and then eventually a black dwarf. Or if the red giant was very massive, it can become a supernova, blow up, its core can become a neutron star, which gives off pulses of energy, or it can become a black hole. Now, depending on how detailed this is, this picture that you drew, if this is really, really detailed, you copied and pasted it, you literally drew and wrote every word, that's all you need. You're done. If you didn't do that great of a job of drawing it and labeling it, then you should probably copy what's in yellow on this slide. Here's our first video. It is the space between stars. So what exactly is in between the stars? You all are going to watch and find out. I have included the links to all the videos on the Edmodo page, so if you want to stop this and go back to Edmodo and click the link, you're good to go. Okay, black holes. They begin as stars with a mass 10 times greater than our sun, and they have a short lifespan due to this mass. Now, we talked about black holes a little bit before. They essentially swallow energy and matter like a giant vacuum cleaner. Light can't even escape it. And most of them are found due to their companion star. So they kind of have a star buddy. And the gases from that companion or the buddy are pulled into the black hole. And as the matter falls into the black hole, right before a burst of X-rays comes out. and that's how we generally find them. Here are two artist renditions of a black hole, and here's a video on it on how NASA accidentally discovered giant black holes. Go ahead back to Edmodo and watch that video also, please. Okay, the Hertzsprung-Russell diagram. This is going to be, I believe, this is, I believe, our last slide of writing. Okay, the Hertzsprung-Russell diagram takes stars and it classifies them. It classifies them on the properties of mass, luminosity, temperature, color, and diameter. Okay, mass, you know what mass is. It's the amount of matter in an object. Luminosity is sort of how bright it is. It's the amount of brightness the star is giving off. Temperature, color, and diameter, you know. Now, every star has specific characteristics related to each of those 1, 2, 3, 4, 5 properties. 90% of all stars fall along the main sequence. Here's the last video. It's how the HR diagram, or Hertzsprung-Russell diagram, describes the properties of stars. Go back to Edmodo and watch that. And this is an image of the Hertzsprung-Russell diagram. We're going to be using this a lot in class. If it looks scary to you, don't worry about it. It's actually really, really easy. I'll explain it. And it should click in your brain in just a few seconds. So don't worry if that looks scary to you. Okay, we're going to ignore that slide. And this is your last one. You have 6 questions that you need to answer in your notebooks. Okay, question 1. All stars begin their life in a blank. Number 2, the blank of a star determines its path or its cycle. Number 3, a black hole takes in blank and blank. Number 4, our sun will eventually become a blank. Number 5, most stars fall in this category along the HR or Hertzsprung-Russell diagram. And number 6, compare a black dwarf and a neutron star. Okay, that is it. Have a good Thanksgiving break.